Hello. In this video, I'm going to show you two new features that we have recently added to the fuzzer EvoMaster. These are, in particular, the use of Docker, the possibility of running EvoMaster through Docker that now is released in Docker Hub, as well on how to use it in continuous integration via GitHub Actions. So let's start with Docker. So here we have introduced simple examples that can be just copy and pasted to try it out, to try EvoMaster, in this particular case on the pet clinic example API from Swagger. So let me copy and paste this, and let me put it in a shell, in a bash shell. This is a Git bash shell. So there is a small modification that I need to do here. I need to add an extra slash. And now what this is doing is that it's going to run Docker. It's going to mount a folder with generated test and run web fuzzing EvoMaster, which is the release of EvoMaster on Docker Hub. And the result then is going to be available in the folder here in generated test. Then I'm going to specify that I want to do black box testing. This is just a simple example, so I'm only going to run it for 30 seconds. And then I don't want to do a denial of service attack on that API, so I'm just limiting the number of HTTP calls that can be done per minute. And then here, then is the URL of petstore.swagger.io. In particular, where the Swagger, the OpenAPI schema is. So I'm going to start the command. So it's starting. So here, the result then will be in these folders once it's completed. So now it's connecting, it's running EvoMaster through Docker. So it will need it's running, it will just run for 30 seconds for the search, and then after the search, there's going to be a minimization phase. And as you can see here, we can just run these things through Docker without doing any installation. Now, the first time you run it, this Docker image will need to be downloaded and installed, but that will be done automatically by Docker. I've run it on this machine before, so this is going to be immediate in this case. Now, let's wait some more seconds. I was recomputing some metrics. And once it's done, it should be here. So now these are generated. Now let's see this one here. Let me just open it. And now a new feature actually, beside the release on Docker, is that we can output test cases in Python as well. So we have 4 different outputs at this point in time, which is Java, Kotlin, and JavaScript, and now the new Python. And so these are just test cases written with unit test. So this is about running EvoMaster through Docker and the new output format, which is Python. Then here, when we run it with Docker, this is just how we run it here. Then the input configuration will be exactly the same as when we run EvoMaster normally from command line, from OS installer, or from directly from a jar file. And if you need more information about how to run it with Docker, we have written quite a bit of documentation that you can find here. So this here is giving some more information if needed. Now let's see about GitHub Actions, how to run this inside continuous integration. So here we have created a new GitHub Actions that can be added on your projects that enable you to run EvoMaster as a part of CI. And here is the documentation on how to set it up. So I have an example project here, a very simple REST API, which I will show you now how it can be configured to run EvoMaster on it automatically. So the actual API doesn't really matter. I mean, whether it's going to be written in Node.js, Go, Python, or whatever. This particular API is just written in Java with Spring Framework. It's a very simple API. It has just 3 endpoints, like get all for some items, finding items by ID, and then create just a post request where to create a new item. So it's just an example API. So let's say that I have this API. I want to run EvoMaster on it in continuous integration every time that there are some code changes. We are going to release, run this API through Docker, because this simplify a lot of things. And especially, we are going also to be able to run it with Docker Compose, because it will simplify how to run it on GitHub Actions. To be able to run these things, EvoMaster in continuous integration on GitHub Actions, we need to have a GitHub workflow. It will start as any other workflow in which we need to build the application. This will be all depends on how you have written your APIs. As I say, whether it's Node.js, Go, C#, whatever. And then we need to start the API. And we do this with Docker Compose, because this also simplify the case when, as part of the API, we also need to start, for example, a database like MySQL or Postgres. And then at the end, we will need to stop the API. So that is easily done with just the Docker Compose down. The actual running of EvoMaster is done here by using the new web fuzzing EvoMaster action, in which then we provide some input parameters. An important one here is write WFC report, because this is just some output files that is generated that is going to be analyzed by the action to be able to provide some summaries at the end of this application. And then the rest are the typical options of EvoMaster. Like we want to specify we are doing black box testing. We need to specify where to find the schema. In this particular case, is on the localhost on GitHub Actions server. This port is the same port that here then in Docker Compose we need to expose, because then this is going to run inside the API. Then this we'll just run it just an example just for 20 seconds. And then we say that if EvoMaster finds any error in this API, we want to fail the build. And then important, we want to save the result. We want to save the generated test cases, because then those can then afterwards be downloaded. So now I'm just going to trigger a simple build. I'm just going to make a small modification here, just to give you a concrete example. I'm going to make a commit. Yeah, this was, I already did it before. And another modification to trigger a build, and then I'm going to commit and push it. This will trigger a new build on GitHub Actions. Now it needs to push it. When I go here, I go on Actions, and I can see that the build started. So let's look at it. Now it's building. It will take some time, because it needs to build the application, then start the Docker Compose, run EvoMaster in it for 20 seconds, and so on. So here we can look at it while it's running. It is a simple API, so the build is pretty quick. Now it's going to run EvoMaster. Now I need to set it up. Now it's running it just for 20 seconds. I removed the progress bar here. because the problem is that otherwise every single update will create a new entry in the progress, which can be slightly annoying. Anyway, here is finished. Now it's doing some post actions, and the build has failed. Let's look at the summary. And the problem is that there are 6 potential faults in this tested application. And so that's the reason why it's failed, because we specified here that if there is any error, we failed the build. Of course, when we want to investigate what is the problem, so the results, we need to look at them. And let me just open it. And these are the test cases that are generated, that can be downloaded on a local machine and then investigated for debugging. And thank you very much for your attention.